The objective for this video is I can describe gases using Dalton's law and Avogadro's hypothesis, and I can identify which gas has the greatest speed using Graham's law. So Dalton's law of partial pressure says that if you have multiple gases in the same container, then they each have their own little pressures, and when you add up all their pressures, you get the total pressure inside of that container. So it's the sum of all the individual pressures. Like in a scuba tank, there's like 6 different gases, and you just add the pressures of each of the 6 different gases to get the total pressure in the tank. So, for example, what is the total pressure in millimeters of mercury of a system containing nitrogen, oxygen, and carbon dioxide in the following amounts? So to solve this, we need to take the sum of all 3 of these pressures, so the total pressure is going to equal the pressure of the nitrogen plus the pressure of the oxygen plus the pressure of the CO2. And so we're going to get PT equals, pressure total equals 240 plus 140 plus 300, which gives us a total pressure of 680 millimeters of mercury. Let's consider this example. A gas cylinder contains a mixture of nitrogen, oxygen, and carbon dioxide. So a total pressure would be of the pressure of nitrogen plus the pressure of oxygen plus the pressure of the CO2. And they're telling us the total pressure is 2.5 atmospheres. So in place of the total pressure, I'll put 2.5 equals, what is the partial pressure of nitrogen? So what I don't know is the nitrogen, so I'm going to put an X, plus oxygen's pressure is 0.6, so that's oxygen's pressure here, plus carbon dioxide's pressure is 0.1. So in order to solve this, these are addition, which means the opposite of that is subtraction. So in order to solve it, I'm just going to take the total pressure, 2.5, and I'm going to subtract by 0.06 and then subtract 0.1. So it's going to go 2.5 and then minus 0.6 and then minus 0.1. And we get 1.8 as our pressure for nitrogen. So nitrogen's pressure is 1.8, and that's atmospheres. Example number 3, air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen at, so this one here is the total pressure, so it's going to be total pressure equals the pressure of oxygen plus the pressure of nitrogen plus the pressure of carbon dioxide plus, and I'm going to put the pressure of trace, and that's going to be for all these other gases that they're mentioning. So we have a total pressure of 101.3 equals, what is the pressure of oxygen when the pressure of nitrogen, carbon dioxide, and other gases are, nitrogen is 79.10, carbon dioxide is 0.040, and the trace gases are 0.94. So to solve this, you're going to just put the total pressure, and then over here, because these are with the X, we'll do the opposite. I will subtract 79.10, subtract 0.040, and subtract 0.94. So we're going to have 101.3 minus 79.10 minus 0.040 minus 0.94 equals. We'll get 21.22 as our answer for oxygen. The pressure of oxygen is 21.22, and that's kilopascals. Avogadro's hypothesis states that equal volumes of gas at the same temperature and pressure also have equal number of particles. So if you have 5 liters of oxygen, 5 liters of chlorine, and they're both at STP, then they're going to have the same number of particles. Equal volume means equal amounts of the gas. So if we look at this question, if all of the balloons above are at STP, then which of the following statements are true? And the question is, all have a volume of 22.4? Well, if they're all at STP, then yes, they all have a volume of 22.4. Do they all have the same number of particles inside? Yes, they do, because they're all at STP. And then, do they all have the same mass? The answer to that question is no, they do not all have the same mass, because the mass in the periodic table is different for each one of these elements. You can have 1 mole of each of these, but you're not going to have the same mass of each of them. So Graham's law of effusion. Effusion is the process in which a gas escapes through a tiny hole in its container. So here's the container, and then there's the tiny hole that the gases can escape through. It's kind of like if you have a little hole in a balloon and the air is escaping through that hole. That would be effusion. Diffusion is the tendency of molecules to move from an area of higher concentration to an area of lower concentration. So we move from high concentration to low concentration in the process of diffusion. So Graham's law of diffusion, the velocity or speed of the particles is inversely related to their mass. So what that means is, the larger the mass, the slower it moves. The smaller the mass, the faster it moves. The rate of diffusion is inversely proportional to the square root of the gas's mass. So let's look at a simulation to understand this a little bit further. So we have 2 chambers. Both of them have the exact same amount of gas, 10 particles of gas. They are both at the same temperature, 300 Kelvin each, but you're going to notice that the speed of the particles is different. And that's because the mass of these particles is 32 and the mass of these particles is 4. The lighter the gas, the faster it moves. The heavier the gas, the slower it moves, assuming that they're both at the same temperature. In this example, we'll see that the process of diffusion, when I remove the divider, is where the particles move from an area of high concentration to an area of low concentration. And there they go. Diffusion is basically gases spreading from high concentration to low concentration. So think of football players. Receivers are usually smaller, lower mass, and that means that they run faster. Linemen are usually larger in mass, and so they run slower. Which gas effuses faster? We have helium versus ethylene oxide. Helium has a mass of 4, and ethylene oxide has a mass of 44, which is way heavier. So that means that this is going to move slower, and this is going to move way faster. So you just need the mass from the periodic table to know. So which diffuses faster, nitrogen gas or helium gas? Nitrogen is N2, which is going to have a mass in the periodic table of 14 times 2, which is equal to 28, versus helium, which has a mass in the periodic table of 4. So which gas is going to move faster? The helium, because it is a lighter mass. Which of these will diffuse faster? Well, we just need to know their masses. H2O has a mass of 18 and CO2 has a mass of 44. So the lighter gas has the faster speed.